Welcome to 9.2. In 9.2, we're going to talk about arithmetic sequences. When we have an arithmetic sequence, what happens is that there is a common difference between the terms in the sequence. Common difference is the name of the game. Our common difference is usually denoted by, it's always denoted by the variable d, lowercase d, and an arithmetic sequence takes on the form a sub n is equal to a sub 1 plus n minus 1 times d, where n is greater than or equal to 1. So a sub 1 will always be referring to the first term in the sequence. This is the word term. And d is, of course, that common difference. So it's kind of a cool reason why we use the n minus 1. It's a cool reason. That cool reason is because n minus 1 kind of accounts for using the first term right here. So that formula is the formula for writing an arithmetic sequence. By the end of the chapter, hopefully you'll have that memorized and you'll be able to use it super speedy fast. All right, let's look at some examples. For part A, we're going to write a formula for the sequence 3, 6, 9, 12, 15. Notice I have a comma and then the 3 ellipses, dot, 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 which just says I can keep writing this sequence forever and ever until I run out of numbers, which will never happen, you know, infinity and whatnot. All right, so I recognize that to get from one term to the next, each time I just add 3, add 3, add 3, add 3. So to write a formula, I'm going to use the common difference of d equals 3. So my formula will be a sub n, or any nth term, is equal to the first term, which is 3, plus n minus 1. This is the expression that kind of like says, oh, I already used that first term, and then times the common difference of 3. So that's that. Now, if you wanted, you could distribute in the 3 and then combine the like terms and everything, but we're going to leave it just like this. A formula, an explicit formula for that sequence. I'm going to write the word explicit with it. Now, if I wanted to write a recursive formula, that's super quick and easy to write because the recursive, remember, is the formula that accounts for the term before it, or you have to know the term before it, and then you just add 3. Remember, this was that previous term. Previous term. Okay, on to example B. So what is the 100th term of an arithmetic sequence? Oh boy, I don't really feel like expanding this sequence 100 terms. Oh boy. Well, I know that a sub 1 is equal to 6. And then from 6 to 11 is plus 5. So that's my common difference. I think I can come up with the 100th term. A sub n will be equal to the first term, 6, plus n minus 1 times that common difference of 5. If I wanted to know the 100th term, or a sub 100, I would go 6 plus 100 minus 1 times 5. On my calculator, I don't know if I still have my calculator up. I do. Let's just calculate this out. 6 plus, 100 minus 1 would be 99 times 5. Let's call that 501. Okay, I'm glad to have this formula because if I would have had to write this out, there's a lot of room for error on my part, and it would have just taken a long time. Life's too short. All right, this next example and last example is my favorite kind of arithmetic sequence problem because you get to do some good old algebra. What we want to do is find the missing terms. We're missing 2 terms from 100 to 82. So I have 2 terms missing in there. And I really don't know what's going on. I don't know how to get from here to there, and then from there to there, and then from there to there. I don't know what the common difference is. So I think I can figure it out. So remember, this is everything I know. An arithmetic sequence is a sub n equals a sub 1 plus n minus 1 times d. Something else I know is that the first term is 100 And I know that, well, you know, this would be the first, second, third, fourth term. So a sub 4 is equal to 82. And then if I just kind of filled in what I know here, n is equal to 4, I could say that 82 is equal to 100 plus 4 minus 1 times, yeah, there's my variable. I don't know what d is. Okay, keep going. This equation doesn't scare me. Subtract 100. 82 minus 100 is negative 18 equals 3d. Those three dots right here mean therefore. Therefore, d must be equal to negative 6. So if I go back and say that's negative 6, and that's negative 6, and that's negative 6, is that going to get me from 100 to something to 82? Actually, it will. 100 minus 6 is going to be 94. Okay. 94 minus 6 is going to be 88. Okay. 88 minus 6 is going to be 82. Done. Perfect. I did it. So my missing two terms are 94 and 88. All right, last thing I want you to put in your notes, and you're just putting this in your notes for future reference, arithmetic mean. The arithmetic mean, or arithmetic mean, is sometimes pronounced arithmetic, I think kind of depending on what part of the United States you're in. The arithmetic mean, or the arithmetic mean, is the number in the middle. It is the number in the middle of two terms of an arithmetic sequence, or an arithmetic sequence. So if I had two numbers and I wanted to know what number would be in the middle of them, you would just add the two terms and divide by 2. That's how you find the arithmetic mean. So if I had 8 and let's see, like 8 something and then maybe 12, this would be the arithmetic mean because it's going to be the number in between two terms in arithmetic sequence. So I would go 8 plus 12 divided by 2. 20 over 2 would be the same as 10. Okay, so that's all I have to say about arithmetic sequences. Hopefully you've got all of this down and you can read your handwriting and all that good jazz. And so arithmetic sequences, a sub n is equal to a sub 1 plus the quantity n minus 1 times d. All right, that's it for today. See you tomorrow.